Hi, I'm Henry Schwartz, President of SecTerm. This video is to show a working demo of an internet security product called SecTerm Keyboard. SecTerm Keyboard is a regular PC keyboard, but it's also a high security pin pad and has a small display screen. The final product looks something like this keyboard that's designed to be used with video games. The central idea is that internet client software, such as a web browser and an email client, run on the SecTerm keyboard and use the PC's existing internet connection. And these internet clients establish end-to-end cryptographic channels with remote servers, communicating via the PC's existing internet connection. SecTerm keyboard is used as a regular keyboard on a desktop PC, with regular applications running on the PC. But for sensitive internet tasks, the most critical steps are performed using SecTerm keyboard's internet clients and user interface, rather than using the PC. Malware residing on the PC is defeated because the data is cryptographically protected as the data passes through the PC. And malware cannot make its way onto the SecTerm keyboard because the software executing on the SecTerm keyboard is locked down in a number of ways. This entire approach of shifting sensitive operations onto a high security user interface device is identical to the technique used by banks to protect transactions performed on ATMs and at the retail point of sale. Let's look at the prototype hardware being used in this demo. We've got an off-the-shelf PC keyboard and a regular high security Vx810 pin pad manufactured by Verifone, and a little interface module that I put together. Please imagine that these three components are combined and integrated into one package, which is the SecTerm keyboard, which, as I mentioned, will ultimately look something like this gaming keyboard. For this demo, I've developed software for 3 different devices. I've written a web browser which runs on the pin pad, some interface software running on the interface module, and a device driver which runs on the PC. The keyboard is PS2 connected to the interface module, and the pin pad uses serial RS232 to connect to the interface module. Then the interface module uses USB to connect to the PC. Here's the keyboard PS2 connected to the interface module, and the pin pad RS232 connected to the interface module. Then there's a USB cable from the interface module to the PC. I've programmed the interface module to be a USB composite device, which means that from the PC's perspective, the interface module appears to be 2 separate USB devices, which you can see in the Windows XP device manager on the PC. There's a HID keyboard device, which is a regular USB keyboard, and there's a communications port, which is how the device driver on the PC communicates with the pin pad. Now we're all set up, so let's use it. This is the main menu for the demo. We'll use Google, then we'll do internet banking, then we'll make a payment. But first, you'll see SecTerm keyboard is a regular PC keyboard. Here's a Word document I'm typing into. Next, on the PC, I'll browse to Google's lightweight website for mobile phones. There it is. Note the text web, images, places, and so on, which we'll see again in a moment. Right now, the SecTerm keyboard is still a regular PC keyboard, but when the user hits a special key, for this demo I'm using the right Windows key, all keystrokes are now kept internal within the SecTerm keyboard and are routed to the SecTerm keyboard's browser rather than to the PC. To indicate that this secure mode is activated, for this demo, on the pin pad I turn on the backlight, and on the keyboard I do a little LED chase sequence. Now I'll instruct the browser on the SecTerm keyboard to visit that same Google site. You can see Google's website displayed on the SecTerm keyboard, with the same text that we saw on the PC earlier: web, images, places, and so on. Because secure mode is activated, I can use the keyboard to tab through the fields on Google's page and enter data. To show that again, the Google search field is empty, then I type on the keyboard in secure mode, and those keystrokes are routed to the pin pad. But SecTerm keyboard probably wouldn't be used for Google searches. That was just to introduce the concept of the browser on the pin pad. For a real application, let's do internet banking. To log in at a bank's website, normally you enter your user ID and password using your PC. But instead, to keep your credentials private and to ensure that this website is your bank and not an imposter, the bank sends a login web page to the browser on the SecTerm keyboard where you enter your credentials and log in. To show it again, the fields are empty, you type in your credentials, and the keystrokes are kept internal and are routed to the web page on the SecTerm keyboard. After logging in, on the PC we navigate to the bank's funds transfer page, where we select the source account, destination account, and enter the amount. But before the bank will accept the transaction, the bank sends a web page to the browser on the SecTerm keyboard, displaying the transaction details and asking for confirmation. Once you OK that, the bank then sends another web page to the browser on the SecTerm keyboard, showing the transaction result. And we're done. All the web pages that we just saw on the SecTerm keyboard, namely the login page, the transaction confirmation, and the transaction result, were all end-to-end SSL sessions between the browser on the SecTerm keyboard and the customer's bank. The data was fully protected by SSL as it passed through the PC. Now let's move from internet banking to internet payments. For payments, I'm currently using the 3D Secure Internet Payment Scheme, which is promoted by Visa, MasterCard, and JCB. 3D Secure is convenient because SecTerm keyboard can piggyback onto it with no changes whatsoever to the merchant's website, and also because the difficult task of recruiting web merchants to participate in the payment scheme is done by the major card associations and their member banks. We start at the merchant's website, where the customer places goods into their shopping cart and enters their credit card number. This is the process for a 3D Secure payment with or without SecTerm keyboard. As an optional convenience, the merchant can allow SecTerm keyboard to provide the card, for example by swiping it, as we'll do here. But this provision of the card isn't really an important part of the solution. When the customer clicks the Pay button, for all 3D Secure payments, with or without SecTerm keyboard, the customer's bank then takes control of the PC's browser to authenticate that the customer is legitimate. Normally, the customer's bank displays an authentication page on the PC. But to make this system secure, the customer's bank sends a web page to the browser on the SecTerm keyboard, displaying the 3D Secure authentication page on the SecTerm keyboard rather than on the PC. On the SecTerm keyboard, the customer enters their 3D Secure password, and then the customer's bank sends another web page to the browser on the SecTerm keyboard, showing the transaction result. And finally, control is then returned to the merchant. Again, those two web pages on the SecTerm keyboard, namely the 3D Secure authentication page and the transaction result, were both an end-to-end SSL session between the browser on the SecTerm keyboard and the customer's bank. The data was fully protected by SSL as it passed through the PC. So I've just shown internet banking and internet payments, but those applications are just the tip of the iceberg. There are some really exciting communications applications for SecTerm keyboard, in which both parties have SecTerm keyboards and they have end-to-end secure communications. For email, the emails are entered into or displayed on the SecTerm keyboard, and the emails are encrypted as they pass through the PC. Or, for voice over IP, a regular headset plugs into the SecTerm keyboard, and the voice data is encrypted and decrypted within the SecTerm keyboard. The final hardware also includes readers for smart cards and NFC wireless tokens, which enable many other applications. Thanks for watching this video about SecTerm keyboard, the most secure internet environment in existence.